Good morning. Conceptually, an important topic, synthetase versus synthase. Both are enzymes catalyzing condensation reactions, as we are going to see in this video. So compare and contrast these two enzymes, which have seemingly similar name. Are they synonymous? The first and the foremost point, no, they are not synonymous. They are quite different from each other, despite their name resemblance. I give one example, fatty acyl coenzymase synthetase. This causes activation of fatty acid to the activated form called fatty acyl coenzyme A. So this enzyme, also called thiokinase, is an example of synthetase. Now coming to an example of synthase, citrate synthase. All of you know the first reaction of the TCA cycle, which is causing condensation of a 4-carbon compound with a 2-carbon compound, oxaloacetate and acetyl coenzyme A, to give rise to a 6-carbon citrate. So this is the first reaction of the TCA cycle. Now, a closer observation will reveal that this reaction is not requiring any ATP, whereas the previous reaction, it required input of ATP energy. So to drive forward any condensation reaction, energy is required. And the energy is provided by ATP in the synthetases. Conversely speaking, synthetases, they catalyze joining reaction, they catalyze formation of a new bond, as you can see here, CS bond, and the reaction is driven forward by hydrolysis of ATP. What about synthesis? Synthesis, I have crossed it already, do not require any ATP. Synthase, not only ATP, they may require GTP, UTP, etc. also. But no such nucleoside phosphate is required in case of synthase. So then from where the energy comes? I'll be talking it at the end of the class or maybe separately. So some example of synthetase is glutamine synthetase. It catalyzes formation of a CN bond. Carbamyl phosphate synthetase. This is an important enzyme of the urea cycle and also in the pyrimidine synthesis. Malonyl coenzyme synthetase. It catalyzes conversion of 2-carbon acetyl coenzyme to 3-carbon malonyl coenzyme. The enzyme is commonly called acetyl coenzyme carboxylase also. This also requires ATP. In fact, all other carboxylases you will come across later are synthetases because they require ATP. Pyruvate carboxylase and anaerobic reaction. Find out what are anaerobic reaction. What about synthesis? Citrate synthase हमने अभी देख लिया. It requires acetyl coenzyme 2-carbon plus 4-carbon oxaloacetate to give rise to 6-carbon citrate. ELA synthase. This is an important enzyme of heme synthesis. ये 4-कार्बन सक्सिनाइल कोएंजाइम ए को कंडेंस करता है 2-कार्बन ग्लाइसिन. Glycine, the smallest amino acid, succinyl coenzyme A, an important TCA intermediate to give rise to ELA, aminolevulinic acid. And then glycogen synthase. Here also, you can see that the substrate is energized. Energized substrate. इस रिएक्शन में एसिटाइल कोएंजाइम में, दूसरे रिएक्शन में एला सिंथेज में सक्सिनाइल CoA. Wherever you add CoA, the thioester, the compound becomes energized. And one more example, glycogen synthase. I'm not going to talk details about it, but glycogen synthase के अंदर the energized substrate is called UDP glucose. Glucose molecule is attached to UDP, uridine diphosphate. So it becomes very highly energized compound. So I think time to summarize now. Requirement for ATP, yes in synthetases, no in synthesis. Examples, we have seen 3 examples of synthase, synthetase KB. You can find out more also. Then one point which will need elaboration. I may do it in a separate video. Synthetases belong to class 6. As you know that there are 6 classes of enzyme and synthase comes into class 4. Class 6 क्या होती है? Class 6, I'm sorry, class 6 bond formation coupled to ATP hydrolysis. This we had seen in case of synthetases. So they belong to class 6, also called ligase. But citrate synthase वगैरह को हमने lyase class में रखा था. Whereas the type of reaction catalyzed, जहाँ तो condensation reaction नहीं है. So why do we call it allies? So what is basis of this classification? I will discuss in a separate video. Source of energy in a synthase reaction. I have given a hint. Thioester, energized substrate. Pyrophosphate cleavage of ATP is another topic, related topic we will be discussing later on. इस वीडियो में जितना है फॉर अ यूजी दैट इज अंडर ग्रेजुएट MBBS दैट इज सफिशिएंट. इससे ज्यादा कोई नहीं पूछता. These advanced learning concepts are mainly for the postgraduates and also for the inquisitive minds. They may be undergraduate students also. So thank you so much.